Hello everyone, I am Ahmad Mojtoba Riyadh. I am a master's student at the Geography Department, University of Utah. The presentation title is A GIS-based analysis of flood resilience in the context of a developing nation. Bangladesh, a Southeast Asian country, has been selected for the case study of this research. I would like to start my presentation with these two pictures side by side. In the left, you can see a picture of Sarasota, Florida, and in the right, you can see a picture of Dhaka, Bangladesh. By the glimpse of these two pictures, you can have an idea how different these two areas are in terms of socio-demographic and infrastructure perspective. So when a similar flood happens in these two areas, the impact would be different considering how the people of this area would perceive the risk, take unique coping strategies, and how they would manage the flooding. Thereby, I thought it would be really interesting to take a modern resilience approach from developed world and use it in a developing world like Bangladesh. In this slide at the top, you can see flooding scenarios in Florida, US, and at the bottom you can see flooding scenarios in developing world Bangladesh. So you can see the differences here. In Bangladesh, a big group of people live below the poverty line, so they cannot afford to stay inside their houses when there is flooding in the community. So somehow they adapt some unique coping capacities and start living with floods. For example, the people uh, who are farmers or who have like livestock, they prioritize their lives more than their own lives, and they try to save them from the calamities. And they also use local resources to build temporary modes of mobility, for example, the raft. Flood resilience is the ability of a system to absorb the impact or shock of a flood and then bounce back to its normal state within shortest possible time. It doesn't necessarily have to go back to the exact state it was before flood. It can be dynamic and can adapt with the system and then still run smoothly. I have two questions for my research. The first one is, how can GIS-based methods for modeling resilience in developed nations be adapted to work in a developing nation context? To answer this question, we'd be using two popular resilience models. And the first one is disaster resilience of place model developed by Susan Carter. And the second one is spatially explicit resilience vulnerability model developed by Tim Fraser. The second question is, what is the pattern of flood resilience across districts in Bangladesh? So Bangladesh is located in the Southeast Asia, to the south of Himalayan mountains, and to the west, north, and south side of to the west, north, and east side of Bangladesh is India, and south side of Bangladesh is the Bay of Bengal. Bangladesh is the biggest delta on earth, one of the most densely populated country, and has the highest number of people around the world exposed to flooding. Almost 80% of the land of Bangladesh is floodplain, and thereby this is one of the most ideal study area for this research. In this map, you can see Bangladesh is located in the middle of three major river basins. In the left, this is the Ganges River Basin that covers a big portion of India. In the middle, this is the Brahmaputra River Basin, and in the right, this is the Meghna River Basins. And three of them merges together and join the Bay of Bengal through Bangladesh, and that's why Bangladesh is so flood prone. Also, due to tropical geographic location, Bangladesh have heavy monsoons that aid in the process of flooding. Hazard researchers around the world have been trying to conceptualize the idea of resilience, and in an attempt to that, Susan Cutter has developed disaster resilience of place model in which she used simple census data and developed resilience scores and weighted index them to develop the ultimate resilience score and visualize it in GIS map. Damien Sferre used DS3 model in which he used critical infrastructure and Cascadian effect to analyze the flood resilience of New York City. Tim Fraser used spatially explicit resilience vulnerability model and expressed the resilience as a function of vulnerability or sensitivity and exposure and adaptive capacity. Flood has had devastating impact in our life throughout the history, and it has caused unrepairable losses to the economy, property damages, loss of lives, spread diseases, and also restrict the mobility. And to protect from flood, people have been trying to develop flood resilience through different approaches. They've been building stronger social community, and we have seen that in Hurricane Katrina that a stronger community can save lives. These are the only single factor that has caused so much devastation to Hurricane Katrina sufferers. And then we have resilient infrastructure, sustainable services, and sometimes government initiatives or private initiatives can help achieve flood resilience to a big extent. The first step of the method is to select the study area, which is Bangladesh, and then collecting the census data and spatial GIS data, then data manipulation to be used for this resilience models, and then reducing the variables through principal component analysis, applying the drop and serve model, and then at the end, key informant interview for validation of the output. The drop model, Susan Carter has divided the overall resilience in 5 categories. The first one is social resilience, then economic resilience, infrastructure resilience, institutional resilience, and community capital. She developed individual resilience score for each of the sectors, and then through weighted index developed the ultimate resilience score. And in SERV model, resilience is expressed as a function of exposure, sensitivity, and adaptive capacity. And in a similar way, it developed the resilience score, exposure score, sensitivity score, and adaptive capacity score. And through the equation, we get the resilience. By analyzing and by imposing the principal component analysis in our 38 variables, we get this covariance matrix to understand the correlation between these variables, and where blue indicates strong positive correlation and red indicates strong negative correlation. And it helps in reducing the variable list and get the desired variable number that we want for our analysis. These are the 15 variables that we got through PCA. The first one is number of households, literacy rate, average household size, male access to newspaper, male economic activity, access to tap and tubal water, access to internet, urban change rate, male access to radio, sex ratio, root population, household disability, population below 5, population above 65, number of fire station. All these 15 variables have been normalized and used to produce the resilience score of individual drop model components. And thereby we get the social resilience map, economic resilience map, infrastructure resilience map, institutional resilience map, and overall resilience map of Bangladesh, where green represents the highest level of resilience, and red represents the lowest level of resilience. Although the overall resilience here does not represent the flooding scenarios, because flood exposure has not been involved here, as drop model is a generalized flood resilience model. So we have to subtract the flood exposure from the overall resilience to get the flood resilience map. And after subtracting, we get the ultimate flood resilience map through a drop model. And it indicates that the central part of Bangladesh is less resilient comparing to the other parts of Bangladesh. And the exposure map at the side would help understand that the areas that are not exposed to flood is highly resilient, and that's why they are being shown so resilient. Now, to apply the SERV model, we need to look at the equation, which is exposure plus sensitivity minus adaptive capacity is equal to flood resilience. And exposure is the culmination of rainfall, elevation, delta plane, and floodplain. Sensitivity is sex ratio, household size, number of household, literacy rate, male newspaper access, male radio access, male internet access. Adaptive capacity is education center, health center, household disability, population below 5, population above 65, poverty score, number of fire stations. And then through these variables and the equation, using the equation, we get the individual map of adaptive capacity, sensitivity, and exposure, and the ultimate flood resilience map through SERV model. If we draw a side-by-side comparison of serve and drop, we can see that there are some differences, but there are also some significant similarities between these two maps, that both of them show that the central part is less resilient compared to the southern part, although the serve model map says that the northeastern part of Bangladesh is the least resilient part. But the experts would say that none of them are wrong, and they would represent a good overall scenario of Bangladesh. And if we could incorporate the local factors of coping capacities and some unique methods they use for surviving the flood, it could fine tune the resilience model a little better in terms of developing nations. So it can be a way forward from here. And that's all for now. Thank you.